Hello children. Last class we learned about what is matter and the three states of matter, the characteristics of the three states of matter. Today we are going to discuss about two topics: interchanging the three states of matter and how to dissolve a solid in liquid, or how a solid dissolves in a liquid. So first we can take a look into the changing of the different states of matter. Which are the three states of matter? Solid, liquid and gas. One state of matter can be changed into another either by heating or cooling. These two processes helps us to change one state into another, one state of matter into another. We can take some examples and make it more clear. First I'll tell you about ice. Ice is which state of matter? Solid state. So on heating ice, what do you get? You might have done it at your home, isn't it? Heating ice. What will you get? We'll get water. So ice on heating gives water. Water is in which state? Liquid state. See, ice is solid. So the molecular arrangement of ice will be like this. You have learned in last class. The molecules are tightly packed with strong force of attraction. So the molecules will be tightly packed like this. And when the solid ice is heated, what happens is the molecules move apart. For example, in a hot climate, if it is a hot night, you ask your parents, if you are sleeping with your parents, you will ask your parents to move away from you and sleep. You don't allow them to hug you, isn't it? Why? Because it is too hot. I am not telling about an air conditioned room, a normal room. You will tell them to move a little bit and sleep because you feel uncomfortable, you will be sweating, you will be uncomfortable, so you don't want them to hug you. Okay? But during cold nights, you love them hugging you very tightly and sleeping. It is very comfortable for you. It gives you warmth, isn't it? So, you love your parents, but you behave in different manners when it is hot and when it is cool. Just like that, the molecules also behave in different manner when it is hot and when it is cool. So here you are heating the molecules of a solid, and first they were tightly packed, but due to the heat they move apart. It means they move away from each other. And when they move away from each other, what happens? The gap between, the interstitial space between the molecules increase or decrease. What happens? Increase. The space between the molecules increases and the arrangement will be like this. Some of the molecules will move apart and the molecules will be arranged like this. So when the molecules have space between them, they are liquids. So solid, when it is heated, some of the molecules escapes or they move apart from each other and changes into the next state of matter, that is liquid. This is called expansion. Okay, this is how one state of matter is changed into another by heating. Suppose if I am cooling water or freezing water, it gives me what? Ice. So water is reversed back into ice on freezing or cooling. What happens when these water molecules are cooled? What happens? I told you, in a cool night, you ask your parents to hug you tightly, isn't it? Same way, when it is cold, the molecules come closer to each other. And when they come closer, they will have a tightly packed structure, or they will have strong force of attraction, and that gives rise to the next state of matter, that is solid. So liquids, on cooling it changes to solid, or on freezing it changes to solid. How? When the molecules come closer to each other. So this is how, and that process is called contraction. It contracts, it shrinks, the molecules come closer. Okay, so this is how heating and cooling causes changes in the states of matter. So one state of matter can be changed into another state only by heating or cooling. Did you understand? Now we can take at the figure given in your textbook. See page number 44, this page, okay? Page number 44, you have a figure given here, figure 5.3. The page number may be different in the revised edition. So you just look figure 5.3 in your textbook. Just open your textbook, okay? Figure 5.3 shows the different stages of conversion of the different states of water. Okay, ice, water and water vapor are the three states of water. Ice is solid, water is liquid and water vapor is gas. So solid, liquid, gas, ice, water, water vapor, three states of water. So here they have given step A, step B, step C and step D. Step A includes the first two figures. Step B includes the second and third figure. Same way, below that, step C includes the first and second picture and step D includes the second and third pictures. That is how that process goes on. Okay. So, about that you have a table in your textbook, this table, and I've written it on the board. Okay. We are going to fill this table according to the process that is happening here. Okay. So, first it is already written in your textbook. First, step A. Step A includes the first two pictures. In the first picture, you can see ice. So, initial state is ice. And it is written heat near that arrow mark. On top of that arrow mark, it is written heat. That means ice is heated. And ice is heated to change into what? Water. So, the changing of ice into water by heating is called melting, and the name of the process is given there, melting. Okay. So, ice on heating changes to water, the process is called melting. Now, second step, step B. I am going to write step B here. Okay. Step B, you have second and third pictures together. Okay. Second picture is what? Water. So, initial state is water. And what has happened to water? It is written heat on top of the arrow mark. So, they have heated it. So, here it is heating. And water, when it is heated, it changes to what? What can you see in the third picture? Vapor. So, water on heating, it has changed into water vapor. So, final state is water vapor. So, water changing into water vapor by heating is termed as boiling. Okay. First one was ice changing into water on heating, that is called melting. Second one, water changed into water vapor on heating, that is called boiling. Okay. Step 3 or step C, you have first and second picture together. So, first picture shows what? Water vapor. So, initial state it is water vapor, and here it is written cooling. See, above the arrow mark it is cool. So, water vapor on cooling gives you what? Water. The water is poured into the ice tray, isn't it? So, water vapor on cooling gives water, and that process is called, do you know what is that process? That process is called condensation. What is it? Condensation. Water vapor cooled down into water is called condensation. Okay, and the last step, step D, gives you these two pictures together. So, here it is water, we already know that. Water is changed into what? Ice. Water. How is it changed? What is it written about the arrow mark? Cool. So, water on cooling changes into ice, and that process is called freezing. Okay. So this is how the different states of matter are interchanged. First one is ice is changed into water on heating. The process is called melting of ice. Second one, water is changed into water vapor by heating. The process is called boiling. Third one, water vapor is cooled into water. Process is called condensation. And last one, water is cooled into ice or frozen into ice, and that process is called freezing. So these are the processes involved in interchanging of one state of matter into another. Is it clear? Now I'll show you another example. Burning of candle. You might have noticed it at your home. Candle is actually a solid substance, isn't it? Candle has a wax part, a wick means tiri. Okay, this wick part and the flame. Okay, a burning candle has flame. The normal candle without burning, it does not have a flame. It has the wax part and the wick. So when this solid candle is heated, what happens? It starts melting. What starts melting? The wax starts melting and the wick is burnt. Okay, when the candle starts, when it is heated, the candle wax starts melting and the wick is burnt. Candle wax starts melting means the solid candle wax starts changing into liquid. You might have done it at your home, burning a candle and trying to make the candle wax fall on your body, isn't it? Or somewhere on the floor or any table or anywhere like that. So candle wax, solid candle wax, on heating it changes to liquid candle wax. Again, if it is heated more, the whole candle wax gets changed into liquid wax. And on cooling this liquid wax, or if you are not doing anything, that is kept undisturbed, what happens? It cools on its own and changes to solid wax again. You might have noticed, isn't it? The candle wax melts, changes into liquid. When it is cooled, what happens? It again changes into candle wax. So here I have shown this candle has completely changed into liquid wax on heating. When it is cooled, it again changes to, when this is cooled, it again changes to what? Solid wax. But the shape will not be obtained. The wax will be in solid state. So this is also an example showing how to change one state of matter into another. Here the solid wax is changed into liquid by heating, and again when the liquid wax was cooled, it has changed into solid back again. Okay, you can just try by lighting a candle at home, okay, with the help of your parents. So this is all about interchanging one state of matter into another. Now we have a different topic, dissolving solids in water. We all dissolve different types of solids in water. For example, sugar, salt, they are all solids that is mixed with water. And it is very interesting to note that when you start adding or start stirring that water containing sugar or salt, after some time we will not be able to see it. What? Is it water that we are not able to see? No. The sugar or salt that was added into the water will not be seen, it disappears. Where does it go? Does somebody go and take it from that glass? No. So we are going to study what happens in this situation. Suppose I am taking 1 glass of water. 1 glass of water. I am showing the water will be made up of water molecules that you already know, isn't it? So 1 glass of water, I am showing the molecules like this in blue color. Okay. Water molecules are not tightly packed, they are loosely packed, they have space between them, and that is shown here. Okay, this is how water molecules exist. And I am going to add some salt into it. I am showing salt in pink color, okay, so that it is easy for you to identify. These are salt crystals, and the molecules of salt will also be in pink color. 1 crystal of salt contains, or 1 cube of salt or sugar contains millions and millions of molecules. Okay, so here we are telling about some number of molecules that is easy for us to draw. So suppose I am adding sugar into this, sugar or salt, whatever it is, we can take it as sugar, into this water. Okay, and when I keep on stirring, the sugar completely mixes with this water. Isn't it? We will not be able to see the sugar anymore. Where does it go? And one more question, when you are taking 1 glass of water and adding 1 spoon of sugar, will the water overflow? Will it flow out of the tumbler or glass? No. So we have to study the reason for that also. So here, when you are adding sugar into water, the sugar molecules occupy the empty spaces between the water molecules. They have empty vacant spaces between the water molecules. That space is occupied by the sugar molecules. Okay, and as it occupies the empty spaces, no extra space is needed by water molecules. So that is why the water will not overflow. Only if sugar takes some extra space, the water will overflow, isn't it? Sugar is taking only the empty spaces. That is why water does not flow out of the tumbler. So when you add both these together, we will get it like this. Water molecules, they have gap between them, and that gap is occupied by what? Sugar molecules. See, sugar molecules will occupy the space between the water molecules. Now can we say that extra space is taken by sugar molecules? No. But water tastes sweet because it has mixed up with water taking the vacant spaces. This is how all solids dissolve in water. And after adding some sugar to it, if you are taking 1 glass of water, suppose you are adding 10 spoons of sugar, it will dissolve. After that, when you keep on adding sugar, it will not dissolve, it will remain in the solution. Why? Because the extra spaces will be already filled up by the sugar that you added first. So no more space will be left, that is why the sugar will not be able to dissolve. Okay, so here one thing that you have to remember is sugar or a solid does not take extra space in water when it is dissolving, it just takes the empty space or the vacant space between the water molecules. Okay, that is how you obtain a sweet solution of water. Now, the liquid which was in more amount, do you take 1 spoon of water and 2 glasses of sugar? No. You add water or the liquid in more amount, and that liquid in which you dissolve a solid is called solvent. The liquid in which a solid dissolves is called a solvent. The solid that you have dissolved in the liquid, that you have added to the liquid or the solvent, is termed as solute. Okay, don't get confused. The liquid in which you dissolved a solid is called solvent, and the solid which you added to the liquid is called solute. And solvent and solute together mix up to give you solution. Okay, so solvent, solute and solution. So here water was the solvent, sugar is the solute, and sugar solution is the final product. Suppose you are making sweet tea. Sweet tea means adding sugar to tea. Okay, adding sugar to tea means you have the tea with you, with tea powder and water you have the tea, that is the solvent, and solute is the sugar that you add to the tea, and the final solution is the sweet tea, that means the normal tea with added sugar that you drink. Okay, coffee, when you make coffee you take water, that is the solvent. Coffee powder is added, that is the solute, because coffee powder is the substance that you add into the solution. So that is the solute. And coffee that you obtain after adding water and coffee powder is called the solution. Clear? Once again I will tell you, solute is a solid that is dissolved in a liquid. For example, sugar, salt and all. Solvent, there is a mistake. This is solvent, okay. Solvent is the liquid in which a solid is dissolved, and solution is the final product that you obtain by adding solvent and solute. I will repeat once again. Solute is the solid substance that dissolves in a liquid. Liquid means the solvent. For example, sugar and salt. Solvent means the liquid in which a solid is dissolved. That means water or any other liquid, and water is called a universal solvent because it dissolves almost all things around us. So it is called a universal solvent. So mainly the solvent will be water, okay, in most of the cases. And the third one, solution, the solvent and solute together form the solution. Okay, you can find out different examples from your home. Try to find out at least 5 examples from your home and note it down in your book. Okay, so this is all about dissolving solids in water. So in this chapter we learned about what is matter. What is matter? Anything that occupies space and has weight is called matter. The 3 states of matter, solid, liquid and gas, and how to interchange the 3 states of matter by heating or cooling, and how a solid dissolves in a liquid or in water. Okay, so read your textbook, study the figures, fill in the table of figure 5.3, fill it in. Read the textbook thoroughly and make it more clear. The properties of solids, liquids and gases should be studied point wise so that it is easy for you. Compare it and study. Write solid, liquid, gas in 3 columns and write the first property. Molecules are tightly packed. In liquids, molecules are loosely packed. In gases, molecules are very loosely packed. So like that, each property should be compared and studied so that it is easy for you. Okay, hope you will read the chapter and make it more clear. Thank you.